Hi, I'm Mary James, Director of Publications at Passive House Accelerator, and this is
James Spill, architect.
And this is our house. I bought the house in 1990, and it was built in the early 1970s. I love living here because of the quietness and the park-like setting here. We have retrofitted the house both to make it more energy efficient and more fire resistant. I've been covering building science and building energy efficiency since 1998. And in 2007, I went to a conference in France that covered building efficiency, and there I learned about Passive House, which is a method of conserving energy, building and designing buildings and retrofitting buildings so that they're much more energy efficient than anything I had ever heard of before. And I got really excited about the topic. In 2009, I applied this retrofitting approach, Passive House retrofit, to my own home. Welcome to our Passive House home. Come on inside and we'll show you some of the indoor features. In winter, it stays warm while using very little heat, and I have no air conditioning, but in summer, there's often a 20-degree spread between the outdoor temperatures and the indoor temperatures. These are our high-performance triple-pane windows, which open like this. They're very solid, and they can also be opened in a ventilation setting, ventilation only, like this. When you do a retrofit of a building, the first thing you have to decide is, are you doing it from the interior or from the exterior? And I chose to do my retrofit, adding insulation and addressing air tightness from the exterior. I was living in my house during the retrofit, so it was a lot simpler to do it from the exterior and also more cost effective. Insulating from the exterior allowed us to preserve the vaulted ceiling look that was always here from the very beginning. I chose metal roofing, both for their reflective capabilities and also for their fire resistance. And the insulation under the metal panels is really important in increasing the comfort in my house because it helps prevent the heat from leaving the house in the winter and prevents the heat from entering the house in the summer. Once you tighten up a building, it's really important to bring in fresh air. And one of the great advantages of Passive House building is that you have 24/7 fresh air coming into a building with heat recovery so that as the air leaves, the temperature of the air coming in is brought up to the temperature of the air leaving. And so we have air being extracted from the kitchen area 24/7 and being supplied over here to the living area 24/7 with heat recovery ventilation. We have further improved our heat recovery ventilation by adding a pre-filter that we only use during smoke events. And that's another great advantage to having an airtight Passive House building because no smoke gets inside. The only air that comes into the building gets pre-filtered to take out the smoke particulates.
So here we are in the downstairs, the basement of the house. And this is our heat recovery ventilator. So this first object is the HRV. So we have incoming air coming through it. It gets pre-filtered. It goes through a heat exchanger with the outdoor air going beside it, and it goes into the house in a steady, continuous flow. There are two hot water tanks over here and a Harvest thermal heat pump on the outside. So that was both the hot water for the house, for the domestic hot water, and it was also the supply heat for the furnace, which is over here. This is our sand and heat pump. It's part of our Harvest thermal system. It uses CO2 as a refrigerant, which is a very low global warming potential. It's very reliable, but it heats all of our hot water for space heating and domestic hot water. Welcome to our kitchen. And I was involved with a lot of electrification of the house. So This is one thing we did to the kitchen, which was change out the gas stove to this induction stove. And we love cooking on it. It's fast and easy to use. Besides the induction range, we also changed out our clothes dryer to be a heat pump clothes dryer. And we have all of our lighting now is LED lighting. This is the center of our electrical system. This is our solar PV comes down into here. We have about 10 kilowatts of solar PV. And then we have this 20 kilowatt per hour battery system. And then we have this controller. And then we have the critical load panel, which just does things that we need if the power goes out. And so it works for both emergency backup, but also we use it for load shifting. So there's two things we have load shifting. One is the fact that we can store a lot of our heat in the house. So we use the stand-in only when the electricity is cheap and clean. And we can also run the rest of the house off the battery when electricity is expensive and dirty. So load shifting, we move the use of our energy to when it's clean and cheap.
On the roof we have 3 solar panels. We have photovoltaic panels to generate electricity. We have thermal panels to heat our domestic hot water. And we have panels to heat the pool. We have no other heating system for the pool. It's only solar.
We have our fruit trees here, fig tree, various varieties of other trees, and a large cherry tree. We're standing on new stairs going down to the yard. There used to be wooden stairs coming up the side of the house. Wooden stairs that are close to the ground are fire hazard and can easily ignite the whole building on fire. So we replaced those, removed those. We also boxed in, it's called boxing in the eaves. Embers will blow up into those eaves and they'll get stuck in there. And that's a great way to catch the roof on fire and then the whole house. We have fiberglass windows, which are fire resistant, double paned. We also covered the house with cement board. These are the 2 HRV vents. This is the exhaust and this is the supply. These are special vents. They're called Vulcan vents. And there's a little honeycomb structure inside this vent. And it is covered with intumescent paint. Intumescent paint, when it gets hot, expands rapidly and it closes off the vent. So the vent will not be venting. It won't be sucking air. No air or embers can climb in through here. It's a really important part of fire hardening. So all of our vents have these kinds of Vulcan vents on them.
Thank you for coming and visiting our home. I know that contemplating a deep energy retrofit or a passive house retrofit can seem daunting. The important thing is to create an overarching plan, and then you can implement it in steps, year by year, to get it done. So it's not as scary as it could be.